Hey everybody, here is number 9 on the homework. Anyway, I'll just kind of get to it. According to a retail organization, holiday shoppers spent an average of $935.58 over the Thanksgiving weekend. The accompanying data show the amount spent by a random sample of holiday shoppers during the same weekend. Test the hypothesis that shoppers spent less than the average over the Thanksgiving weekend using an alpha of 0.05. So I went ahead and I opened it and I put it here in Excel, and then I took the formula here to find our t-test statistic, just so we could have it later. You can always find the formulas by going to view an example. Okay, there's always, you can just get the formula from there, or you can look it up in the book if you forget it and don't, or you probably have it in your notes too if you've gone through the lecture. So the first thing we're supposed to do is determine our null and alternative hypotheses. So always remember that our null hypothesis, or H sub 0, is that the population mean is, well, not always, but in this case, it says we're testing the hypothesis that that shoppers spent less than the average. So our null hypothesis is that things are the same as they've been before, which is that it is greater than or equal to the average, 935.58. So our alternative hypothesis would be that it is less than 935.58. All right, so now we're supposed to determine the appropriate critical value. So I'm going to just start with the information I have here. I have alpha of 0.05, and I've got my, I guess you'd call it my testing mean, or the amount that we think that we're testing for. I'm just going to call this my null hypothesis mean. So it says test the hypothesis that they spent an average of this much. So 935.58. Right, and it's this thing right here, okay, which is the population mean of the null hypothesis. Okay. I also can find my sample mean, which is x bar. I can do that just by doing equals average and then highlighting the whole data set. And then I also know my little n, which is the number of data points. Here I can just look at it and see there's 16. If it was a really big group or something, or I could also always do equals count and then highlight my data set. So I think that's all the info I have. So to find my critical t, first I've got to know what I'm doing. If it were a two-tailed test, I'd be finding the t of alpha divided by 2. But this is a one-tailed test, right? Because this isn't equal or not equal to, it is, I'm testing that it's less than. And so because I'm testing that it's less than, which is my alternative hypothesis, is that it's less than this mean, 935.58, I'm going to say I'm testing for the negative critical t, okay? This equals t dot inv. The probability is our alpha, and the degrees of freedom is n minus 1. All right, so now we have to calculate our t-test statistic. So we're going to use this formula, and it's not as scary as it looks, okay? In fact, I'm going to need one more piece of information to do it, which is the sample standard deviation. I'm going to do equals stdev dot s for the sample, and then just highlight my data set. So now I'm ready to do this. So the numerator is going to be x bar. Whoops, I didn't do an equal sign, sorry. Equals x bar minus my null mean divided by my sample standard deviation over the square root of n. So that'll be my t-test statistic, 0.04 or 0.40. Oh, it wants negative, sorry. That's my bad. All right, so now we have to come up with the conclusion. So we know that our critical t is negative 1.75, and that our t-test is negative 0.39, which means this is our t-test is close enough to the mean. In fact, it's pretty close to the mean, right? It's only 0.4 0.4 away, 0.4 below the mean. So do not reject the null hypothesis. There's not sufficient evidence to conclude that shoppers spent less than the average of 935.58. So even though in our sample here, it was less than the 935, given our alpha of 0.05 and the size of our data set, this isn't enough less that we can truly conclude whether or not this is a change to a likely change to the population mean, or just caused by variation in any normal data set. Let's see, estimate the p-value for this test using the provided distribution table. So let's see. So I think, let me look at something here. All right, so I had to pause it and figure this out because, well, I always just use Excel. I don't use the table, and this was forcing us to use the table. So you can see the answer I got here is one tail greater than 0.2. All I did was open up the t-distribution table. Here's my test statistic, and I took the absolute value of it, 0.39832. And then I took my degrees of freedom, which were 15. And you can see that as I move this direction on the table, I'm getting further and further away from my 0.39832. So I knew it had to be with one tail. The highest this table went is 0.2, and so since I still hadn't reached my 0.39832, I just said it had to be greater than 0.2. It had to go this direction still. So it was one tail, which I knew it was a one-tailed test, and greater than 0.2. Then it says to use Excel to find the actual p-value, which is what I normally do, which is why I was, I guess, confused by that one. And there I'm just going to use equals t dot dist. For x, I'll use my t-test. And then for my degrees of freedom, I'll do true, or I mean, sorry, I'll do n minus 1. And then true. And I come up with 0.348. Let's see, we're doing less than, right? So there we go. Okay, so I hope that was helpful. Sorry I had to do that little pause, even though it didn't feel like a pause to you, but that I had to explain that one, but it's because I always just use Excel to find the p-value. Anyway, have a great day.